Greetings and welcome, friends. Me, Mr. Waddy, and my algebra buddies are here. We were talking yesterday, Trinley, about solving compound inequalities. Me and Trin Dog were hanging out, and we were solving these problems. And we also noticed that compared to equations, which had typically a solution, inequalities had infinitely many. All right, so here I've got this graph. It says, write a compound inequality that is represented by the graph. And perhaps you can see that, my online friends, that it's shaded in between these values, and it's got an open circle at 7 and 14. So does it include 7 as a solution? No, because it's open circle. How about 14? No, for the same reason. Now, do you guys suspect this is an and or problem? Now, or problems are when they're shaded away, and problems are when they're shaded towards one another. So because this is in between, this is an and problem. And problems, I would write from least to greatest. So what's the smallest number that you see? Yeah, Caitlin? 7's the smallest thing. X is the in-between stuff. And 14 is the biggest thing. And now it's in least to greatest, so all of my signs are going to be less than signs. And do either of these signs need to have an equal part on them? No, right? If they had equal parts, those would have been closed circles. All right, so that's one of the ways we can do that problem. All right, here it says for question 8, write the sentence as an inequality and then graph. So it says the number n is, let me analyze the relationship, is less than or equal to something, or, greater than another thing. So I saw the keyword was or, so I don't need to write it with the and form sort of thing. I'm going to have an or in the middle here. And I'm going to have, a number n, they even told me n, is less than or equal. So here's a less than or equal to sign. -7, like so. Also, I put the line through my 7s so that my 7s don't ever accidentally just start looking like a greater than sign, right? Because that could happen. Or n, the same variable, is greater than 12. So here's greater than 12. Notice not greater than or equal to. So if I want to graph this, graph this, I'm going to have 0. We'll call this -7. 12 is going to be further away from 0 than -7. And now I've got to graph it, right? Right there, Jake? Yeah, Jake squad. All right. So n is less than or equal to 7. So what type of circle will this be? Closed, yeah. All right, closed circle. Less than is left then, right? Shaded to the left. And at 12, open or closed circle, friends? Open, and shaded greater than is to the right. The positive x-axis is in that direction. So far, we've just been kind of interpreting these and graphing these. But then we had some solving problems. And just like solving equations or inequalities before, I'm trying to get the variable by itself. Question, comment, observation. Yeah, so if this wasn't here, I would have just gotten r by itself by dividing both sides by -3. Notice I'm not adding 3 to both sides because it's being multiplied by -3, not subtracted. And so if I would have divided both sides by -3, hey, when there's 3 sides, let's divide all sides by -3. And wait a minute, guys, I just said, I said the magic word. I said negative and divide in the same sentence. What? So let's see. So this is -8. R is left here. -9 divided by -3. Those minus signs cancel out. 3. Yeah. There we go. And that divide and negative thing, what do I have to do? Flip that sign. So this one's going to get flipped. And this one's going to get flipped. It's still got that equal part, like so. And so let's see. So I'm going to have on my graph, here's 0, here's 3, -8 somewhere over here. Notice my graphs, I'm not super fancy about these. Right, Jake? Right. I'm not looking for anything fancy. Just try to make it look like the -8's further from 0 than the 3. I'll graph in purple this time. So is this a shaded away or shaded towards? Uh-oh. Uh-oh. Well, the R is in between the two numbers, so the shading is going to be in between the two numbers. So this is an AND problem. You could think about it that way. So it's going to be shaded towards itself. The inside is going to be shaded. So it's going to be open circle at -8. And if -8 is less than R, that means R is the bigger stuff than -8. And it's going to be a closed circle at 3. And if R is less than or equal to 3, R is going to be over here. And notice, oh, it's shaded in between. They met in the middle. It's like they were digging a tunnel through a mountain from two sides for some sort of railroad track. And they met in the middle. Oh, it was amazing, this wonderful moment. Oh, that would be math, my friends. Trigonometry would answer that question. How do you dig two tunnels on different sides of mountains and meet in the middle? Or you could just maybe go to some Minecraft channels. I'm sure they'd be able to help you out as well whenever you've been solving that problem. Yeah, of tunneling through a mountain from two different sides. So for this OR problem, guys, solving OR problems is actually even easier. It's just like solve two problems. You don't even have them interfere with each other, really. So over here, man, represent with the Jacob. What? Subtract 8 both sides. Do I have to flip that sign? I don't. I don't. All right, over here, divide both sides by -8. That's kind of weird that there's similar numbers here. So I've got V. Oh, but I wasn't subtracting 8 there. I was multiplying by -8. And the opposite of multiplying is dividing. So let's see, -40 divided by -8, positive 5. I don't know, it just happens. And wait a minute, divided negative, what? Flip that sign, what? And we'll throw an OR in between these. And the fact that it's an OR problem, is it going to be shaded towards or away? Or way is right. We're going to shade, no, that's not going to help anyone remember this. We'll be shading away from each other. So this one will be easy to graph. Positive 5's over here, about the same distance away, exactly the same distance away as -5 on the other side. And open circle less than, and open circle greater than. All right, Jake? Yeah. Jacob, that is. So yeah. Jake squad. Yeah. All right, so solving these inequalities, it's the same process. You just got to remember you flip the sign if you divide or multiply by a negative. And if there's 3 sides, you do the same thing to all 3 sides. All right, let's look at this boss fight right here. What? Oh, Jake squared. That's a pretty good one too, yeah. So boss fight. All right, so you're thinking distribute. I'm a fan of distribution. That's not my only first move I could have done. What's another thing I could have done? Does anyone know how to deal with that 1/2? I could divide everybody by a half, which is the same as multiplying by the reciprocal. But we'll do distribution. That's usually the result, the normal method. So -12 is less than, what's half of 4x? 2x, and half of 16 is 8. Man, this is, guys, I think we're going to be ready for this test tomorrow. This is great. All right, slow down. Let's make sure everyone's caught up. So there are 2 things happening to x. It's being multiplied by 2 and added by 8. You're saying I should subtract 8 from, oh, just over here? Oh, just those 2 spots? Yeah, subtract it from all 3 sides. All three sides. All right, that's only fair, guys. It's only fair, right? If you and two friends are going to a theme park, it's going to cost you $8 to get in. All y'all's paying $8. No theme park. I don't know. Maybe it's not that great of a theme park. So negative 12 minus 8 is negative 20. Oh, do I have to flip that sign? Why not? That was negative. Try to trick you guys. You're too good. You're too good. And 18 minus 8 is 10. Okay. Next, divide by 0. Oh, 2. All right. Ben, do you agree with that move? All right. So it's being multiplied. Who do I divide by 2? Everybody. And my 2's are starting to look like Z's there. Yep. 1x or just x? Do I have to flip those signs? Oh, wait, what about this one, though? Because negative 20. Because I divided by a positive, I don't have to flip it, right? I don't care about the sign of the numerator. And numerator, yeah. So, is this going to be a shaded towards or away? It's an and problem. X is in the middle, so the shading would be in the middle. I'm not going to graph that one for sake of time. All right. Last problem. I want to get C by itself. All right. Slow down. Yeah. Subtract 4, all three sides. I agree. And let's have some. We'll have Trinley tell us the next step once I get there. 18 is less than negative 3C is less than 10. Ooh. All right. So what are your thoughts? How do I get C by itself? You can pretend this isn't here for a minute. I like it. Yeah, it's being multiplied by negative 3. So inverse operation is divide everybody by negative 3. This one's going to be a little bit ugly over here, but that's fine. And so 18 divided by 3 is 6, but of the negative variety. The C is, in fact, by itself, because notice the benefit of dividing by negative 3 is those all just cancel out, right? That's what I wanted, C to be completely alone. I've taken all of his friends away. Yeah, and this is negative 10/3. Oh, flip that sign. I like it. And why am I flipping the sign? I divided by negatives. That's right. And tell you what, I want this to be written from least to greatest. So I'm gonna flip the entire thing. All right, I'm gonna take this entire thing and just like flip it. All right, entire thing. So I'm gonna have negative 10/3. Here, Jacob, come on. This sign is now over here and flipped. This sign is now over here and flipped, and it looks something like that. Now, negative 10/3 you could also think of as negative 3 1/3. You could also think of as about negative 3.3. Or exactly 3.3 repeating. All right, so if I wanted to graph this, I've got 0, 1, 2, negative 3, 1, 2, negative 6. Is this going to be shaded between or away? Yeah, because, the variable is in between. It's going to be, shaded in between. I'll have an open circle at 6, negative 6, and an open circle at negative 10/3, which is the same as negative 3 1/3. Is that here or here? Left or right? This is negative 2 2/3. Here's negative 3 3/3. So yeah, something like that, and shaded in between. All right, well, thanks for watching, Internet friends. Good luck on your test tomorrow, Internet friends, from Past Waddy.